This video will teach you a little bit about horizontal asymptotes. A horizontal asymptote is a y-value. When we graph a function, the function usually never crosses a horizontal asymptote, but sometimes it can depending on the particular function. The function will always continue to either decrease or increase as it approaches a horizontal asymptote. It never becomes constant. Looking at the graph, suppose that we have a horizontal asymptote at the value of 2. Now if we have a graph that is decreasing, what typically happens is that the graph will go down to the horizontal asymptote and then continue to follow it along forever to infinity. Now keep in mind, sometimes a graph does cross a horizontal asymptote, but usually it just follows it along, and it will always, in this particular case, decrease since the function is decreasing. When it gets closer and closer to the horizontal asymptote at the end, it's decreasing by just a small amount. We'll look at the steps on how to find a horizontal asymptote. You first look at the degree of the numerator and compare it to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, then the answer is always y equals 0, which is also the x-axis. So this would give us a horizontal asymptote along the x-axis. If the degree of the numerator is equal to the degree of the denominator, then the answer for the horizontal asymptote is found by the fraction of the leading coefficients. And finally, the third case is if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Now let's take a look at a few examples of finding horizontal asymptotes. The first problem is f of x equals 3x divided by x to the third power. Now this function can be reduced if we factor out an x by 3 divided by x squared. The degree of the numerator compared to the degree of the denominator will tell us what the horizontal asymptote is. Looking at the numerator, there is no x, so the degree would be 0, and the degree of the denominator is 2. So we have 0 is less than 2, and looking at the rules of a horizontal asymptote, the answer is y equals 0 or the x-axis. In the next problem, the function is g of x equals 4x to the third power minus x squared plus 1 divided by 2x cubed minus 6. Again, we need to compare the degree of the numerator to the degree of the denominator. The numerator has a degree of 3, and the denominator also has a degree of 3. These are, of course, equal. So the rule says that we need to look at the fraction found from the leading coefficients. And the leading coefficients are the numbers in front, 4 and 2. So the fraction is 4 over 2, which reduces to just 2. So this function would have a horizontal asymptote at the value of 2. In the last example, the function is 3x to the 6th power minus 4 x squared divided by x squared plus 3. The degree of the numerator is 6, and the degree of the denominator is 2. So 6 is greater than 2, and looking at the rules, if the numerator's degree is greater than the denominator's, there is no horizontal asymptote.